times, okay, what is S1? S1 is C1, 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 C0, C1, C0, C0, dot S2, which is C0, C0, C1, C0, C1, C1, C1. For clarity, let me draw these two on top of each other. So this is kind of like if you have to calculate, if you have to manually calculate a multiplication, this is sort of the same idea. I want to line up all the coordinates. So what am I doing? I'm taking the dot product of these. So what I'm doing is I'm multiplying them together component-wise and adding. So again, I can break it down by chip. So I've got these 7 chips. And so what I get is, for one thing, it's important to note that dot product is commutative. So basically, C1 dot C0 is the same as C0 dot C1. So I have 1, 2, 3, 4, C1 dot C0. Plus, how many C1 dot C1? 2. Plus, how many C0 dot C0? 1. So by aligning them like this, I can see how to take the dot product by grouping the chips together. So I get 4 C1 dot C0 plus 2 C1 dot C1 plus 1 C0 dot C0. Okay, these we already know. What's C1 dot C1? It's NC. So that's 2 NC. And that's NC. What do you think C1 dot C0 is? It's a negative NC, right? Because C1 is -1, and so on. And C0 is just 1, 1, and so on. So each of these components, if I multiply them together, is -1, and there's NC of them. So this is -4 NC plus 2 NC plus 1 NC, which is equal to negative NC. Okay, so we have S2 dot Sx is 1 over root 7NC times S1 dot S2. This we've established is NC, negative NC. So I end up with minus NC over root 7NC, which is equal to minus root NC over 7. So this is the cross correlation. Now notice that if we already had an orthogonal basis, then S2 should not have anything in the Sx direction because Sx is just a scaled version of S1. So therefore this should be 0, but it's not. So that means these two basis vectors are non-orthogonal to each other. Okay, so finally, redraw that. We have the numerator of that expression was S S2 minus S2 dot Sx times Sx. Which is S2 minus, actually now it's plus root NC over 7 times Sx. So what I'm going to do, I'm going to, it's going to be a big pain to write all of this out, so what I'm going to try to do is I'm going to try to take the norm of this. So basically what I have to do is take this, divide it by its own norm. So I mean, what you could do is you could certainly write everything out, calculate what these vectors actually are, but that I think is going to be a pain. So let's not do that, and instead let's just say Sy is equal to S2 minus root NC over 7 x divided by the norm of that. Plus. And that norm, S2 plus root NC over 7 Sx is equal to S2 dot, excuse me, S2 plus root NC over 7 Sx dot itself square root what I need to do now, I need to notice that multiplication works like, dot product works like multiplication, so I can distribute this multiplication over the addition. So I get root S2 dot S2 plus 2 root NC over 7 S2 dot Sx. Well, there's two of those because I take that dot and then this dot, and finally I get this, which is root NC over 7 squared, so it's just NC over 7. Sx dot Sx. Okay, easiest thing is this. What is that? Sx dot Sx. It's already normalized, so it's 1. So that's 1. This, I just did over here. So that is minus NC over 7. Minus root NC over 7. And this, okay, S2 dot S2, what did we just do? We just did S1 dot S1. And that turned out to be 7NC.